Hey there, how's it going everybody? So in this video we're gonna be learning how to build our own models within our GIS project. So as you have seen in the previous tutorials, we had to create our several analysis functions in order to achieve our main goal. Okay, so as you have seen here, we created this stats within 100 meters only, and then we created a summary, and then we also created a buffer. But what if I told you that by using a model we just lay out everything in just easy to use steps and easy to recognize steps that we can also be effective, especially when you need to share our models with other people in the outside world. Okay, so in order to build our model, what we're going to be doing today is we're going to be building we're going to be going through the same steps that we took in our last 3 videos, but this time we're going to be building a model. So what I'm going to do here is I'm going to turn off all the layers that I have managed to create whilst we're analyzing this data within our last 3 videos. Okay, so let's just turn this off. So I'm just gonna remove these layers and remain with our default data, as you can see here. Okay, so that's our default data. So what we did in the previous video is we created a buffer range, which is 100 meters, and then we created a summary statistic, and then we created a clip in order for us to filter all the irrelevant data. So we're just going to do this using a model. So in our analysis tab, let's just go and click on model builder, which is right here. So I'm just going to click on that, and it's going to open our model builder panel. Okay, so this is basically where we're going to be building our models. Okay, like I have said, we created a buffer, a summary, and then a clip. So what we want to achieve here is the same goal that we did in the last 3 videos. So first of all, when creating a model, this is a combination of our data and our tools. As you can see here, we have everything that we basically need in order to complete our model. So this is just going to be a basic model without any logic, so we're not going to be using most of these functions. Okay, so now what we want to do is we want to create a buffer within our pumps. So what we need to do now is we add our pumps. We just click on this dataset, and then we drag it into our model like this, and then our data goes into our model builder panel. Okay, so now what we want to do is we want to create a buffer. So we find a buffer as under our tools. Okay, so let's just click on tools. We're just going to click on this arrow, and then I'm just going to type buffer, and then I'm just going to double click right there, and my buffer function comes into play. So what I need to do is I need to create a buffer for these pumps. So I'm just going to drag my pumps and connect to the buffer. Okay, and then I specify that these are my input features for the buffer. Okay, so that being said, what I need to do now is I need to specify the output layer for this buffer. So I'm just gonna right click, and then I'll rename this to 100 meter range buffer. So I've renamed this output feature, and now I need to specify that this is a parameter which is going to be used by the buffer. And then now within the buffer, I need to right click and in order to configure some properties. So I'm just going to go and create a variable, and then from parameter I need to specify the distance, and then this 2 comes up here where I need to specify the distance. Then I need to right click on this 2, and then I go on I just go on parameter. Yeah. So I've made this input a parameter to the buffer that I need to run, and then I also right click again, and then I click on open. So okay, so now this is where we specify our distance parameters. So we need a buffer which is 100 meters from our pumps, and then I specify a length unit, just going to be 100 meters there, and then I click on OK. So here, as you have seen, the colors for our model have changed, indicating that this model is valid. If your model is not valid or is incomplete, they will remain with the colors unchanged. Okay, So I think that's it. Okay, so now what I need to do is we need to summarize the statistics that we have found within this buffer. So I just go on tools again, and then I type summary. Okay, so it was summary within. Remember, it was summary within. So just type summary within, and I click on enter. As you can see here, there's a summarize within analysis tool which you can use. I'm just gonna double click on this tool, and then it comes right here. Okay, so within our summary statistic, our buffer output is going to act as an input to this summary function. So what we basically need to do is we just need to connect these again like what we did, and then this is going to act as an input polygon. Okay, as an input polygon. Remember, what we need to summarize is the number of colored dots, so that means we have to add the colored dots again as another input to this summary statistic function, and then we click on input summary. So we need to call this an input parameter, so we specify it as an input parameter just like that. Okay, so in order to verify that if it's an input parameter, we are able to visualize with the P symbol. We specified our input parameters, so now what we need to do is we need to rename our output features. So I'm just gonna rename this. So this is going to be a polygon output. So I'm just gonna rename it to summary polygon. Okay, and then I need this going to be a summary table. Okay, like that. And then finally, what we did is we then had to use the clip function in order to filter our data. So I'm just going to go on tools again. I'm just going to search for clip, and there is our clip. We just double click it, and it comes into our model workspace. And then our summary polygon is going to act as an input feature into our clip. Okay, we can also use this 100 kilometer radius buffer also, but I like dealing with a straight workflow which is not that complicated. So since this is a polygon, it's going to act as our base layer. So when we connect it, it's going to act as our clip features. So this is going to be our clip features. So we need to clip all the dots which are within our specified summary. So that means we need to add our dots again as an input parameter here. So we just connect these dots again, and then we specify that this is our input features. So you can see the layer is now valid. So what we need to do now is we need to rename this and call it filtered data. Okay, and then we specify. Okay, so before I do anything now, I need to validate this model. As you can see, I validated the model, and there were no errors where it been shown. And I need to auto layout in order for this model to make sense. Okay, as you've seen, it has been automatically fixed, and now I fit it to the window so that we see everything that has been built. It's been done by this model. Just gonna relay out this. Just gonna say to fit. Okay, so I'm just gonna leave that. Okay, so now then we need to verify that everything within our model is actually correct. So as you can see, this summary polygon is feeding into the clip. So we need to specify that this is an input parameter also. And then let's check to see if there are any other parameters. So this color dot is now the input parameter. Okay, so now what I need to display within my project, I only need to see the filtered dots from our data and remove all the irrelevant. So I need to see these results only. So I'm just going to right click here and say add to display. Okay, so this is what is going to be displayed as soon as this algorithm runs. So let's just make sure we save our model first. So I've saved the model, and then we validate, and then we run our model to see if it works. So as you can see, it's now executing our model. So right now it's on buffer, and it is executed the buffer. Is now executing the summary within. Just gonna give it a few more seconds to complete. It's now drawing up the summaries. It's writing the features. It's now on number 100. Just give it a few more seconds until it's done. As you can see, there are no errors so far within our model. Still running 75-100%. It's still running the second process out of 3. Okay, it's now executing the clip. It's now assembling all the features. Okay, so our model has been successfully completed. So now what we need to do is we just need to close this model and go back to our map and see if what our data was actually, if our model was actually valid and produced the results that we wanted. Okay, so now these were all the stats that have occurred. So I'm just gonna bring back I'm just gonna see if our data was actually filtered. Okay, so this is our data which has been filtered, and this is the initial cholera data. As you can see, there's a difference within this data set. So I'm sure if you still have your data, unfortunately I removed mine. I removed my buffers, but we could actually overlay and see that the distance which was within the buffer is still the same. Still the same data that has been clipped, like just like what we did in the previous 3 videos. Okay, so this is how you create a model. Okay, so let's just go back to our model. Okay, so this is how you create a model when you are running, when you want to perform tasks in an easy to use and easy to share way. Unfortunately, I didn't get to specify that this summary table should be added to the display, but if I had specified that, we'd see a table here. I'm sure you guys can do that on your own when you're going through this tutorial and see what the table is going to look like. Okay, so there's several things that I also need to mention within this model. We have several options of sharing this model. You can see here, if I go to report here, I can export to a Python file, I can send to Python window, or I can export to graphic. So let's say you're working on a project, and then your supervisor or your lecturer or whoever wants to see what models you used to come up with a certain result. You can just export this to a graphic. So I'm just gonna click on export to graphic right there. Okay, so I've clicked export to graphic. So it wants me to save this as an SVG file, or I can save it as an Adobe PDF. So I'm just gonna save this as a PDF. So let me just save this within my documents. I'm just gonna say creating a basic model. So I'm just gonna save this as a PDF. So yeah, I've saved that as a PDF. We can also export this model as a Python script. If I was to go on export, we can also export to Python file. It's going to prompt us to save this as a Python file. So let's just save it as a Python file and see what the file looks like. I'm just going to say creating a basic model. I'm just going to remove the PDF extension, and then I'm just going to click on save. Okay, so we have saved it as a PDF, and we have also saved it as a Python file. Let's just go to our documents and see how this actually looks like. So I'm just going to go to documents. We saved this as creating, so I'm just going to go on C. Just going to go on C, creating a basic model. As you can see here, So I'm just gonna open this PDF. My computer is taking quite long there. Then I'm going to open this using Google Chrome, because if I try to open using Adobe, my computer is just basically going to freeze and it's just going to take time. Okay, so let's just leave the PDF to load so that we see what exactly did we create. Okay, so this is our model in graphical format. So whoever you share this model with might need to know which tools and methods did you actually use to create your models. Unfortunately, I left some parts of this model which could be useful, especially when you're sharing. Okay, so as you can see here, there are quite a lot of features that you can use, but one feature here is, let me just show you one. We just create a label for this one. So I can just label this and say this is the pumps data set that I used as my input for the buffer. Okay, so as soon as you export this, while at least you have labeled it, anyone who's going to be visualizing whatever model that you send to them can easily understand. Okay, labeling also helps, especially when you're going to be making comments about these models that you're going to be sharing with everyone. So this was our model in graphical format. Let's just try to see what our model looks like in Python format. So I'm just going to open this using Visual Studio Code. For those who like to code, especially using Python like myself, I think this can be a really helpful tool for you guys to actually export these models into your web-based applications or desktop applications and allow users to perform certain queries without actually having to get GIS software. And also, while it's opening, I can also mention that these models can also be used within our ArcGIS Online platform. Okay, yeah, I will show you how to do that within our ArcGIS Online platform in future videos to come. But for now, we're just going to focus on dealing with this in our desktop software. So let's just wait until our Visual Studio is open, and then we see how the Python script actually looks like. Okay, there it's still loading. Let's just give it some time to load. Okay, let's just expand this window and just wait a bit. Okay, as you have seen, I'm sure all those who are familiar with Python know how we can know how to interpret this type of code. As you can see, it comes with comments. Okay, I'm not gonna go much on this, but I'm sure everyone who likes coding, who creates applications, can actually embed this code into their applications to improve functionality and allow users to actually execute certain queries and functions without having to get GIS software. Anyway, I hope this video was helpful for you guys, especially when you're creating your models, and hopefully it's going to be easier for you to perform those tasks in an easy to use method. And I also hope that you're going to be sharing these models with your friends and your co-workers. Anyway, if you like this video, please share, subscribe, and like this video in order for us to keep creating more of this content. See you guys in the next tutorial.